For my submission, I created the Virtual Analog Plate Reverb plugin. A real plate reverb unit uses a 2x1 meter steel plate with a thickness of only 0.5 millimeter. A tiny speaker attached to the plate sends sound in, which is then picked up by two small microphones at either side of the plate. A virtual analog simulation of this would result in a digital sound effect, while preserving the sound of the classical analog effect, as the simulation relies on a model of the physical plate. The model uses physical parameters, such as material density and dimensions of the plate, to create the output sound. There are some plugins out there, such as Valhalla Plate and the PA1 Dynamic Plate Reverb, that use virtual analog simulations for their plugins. To my opinion, however, they don't make full use of the potential of these simulations, but I will come back to that later. In physical modeling for real-time implementation, speed is naturally of the essence. I researched different techniques to implement the plate reverb virtually: finite difference methods, feedback delay networks, and modal synthesis. Eventually, the latter had the best speed-quality trade-off. A plate mode can be described as a plate shape that oscillates up and down. Modal synthesis adds many different modes together to eventually create a, say, more specific plate shape. Over time, the strengths of the modes change, resulting in the plate shape over time. The more modes are included in the model, the higher the quality of the implementation, but also the more processing power it needs. Even though I use modal synthesis as my implementation approach, speed was still a huge issue during the process of this project. I based my plugin on an implementation shown by the creators of the PA1 Dynamic Plate Reverb in this paper. The authors describe a way to exclude modes from the implementation that are less perceptually important. Every mode has a unique eigenfrequency, and if there are multiple modes with almost the same eigenfrequency, we can keep one and exclude the rest, as we perceive them less. The great thing about virtual analog simulations is that parameters that are physically fixed can be made virtually dynamic. After taking a look at all parameters that the model relies on, I found that the most interesting to make dynamic were the length and width of the plate and the microphone positions. The PA1 plugin allows the user to change these, but doesn't dynamically alter the sound while it does this. Let's take a look and listen to the plugin. Of course, the dry and wet slider controls how much of the dry and wet signal is present in the output. Let's put it all the way to 100% so we can hear the changes in the other parameters more clearly. The plate height and width control the dimensions of the plate. In the model, this changes the value of the eigenfrequencies while keeping the strengths of the modes they belong to. This creates a pitch bending effect. The quality slider reduces the number of modes in the way I mentioned before. To apply any changes, the plugin must be reinitialized by moving this slider from off to on. The flanging slider turns off or on the moving microphones. They move in the following Lissajous shape. To create a more immersive stereo effect, the right microphone moves twice as slow as the left, and the only parameter that the user can change is the speed at which the microphones move. The rest is set. As you could hear when changing the plate dimensions quickly, the stretching sound was delayed. Before, when the plate was stretched too fast, there would be jumps in the sound. I then introduced a smoothing factor that would kick in when the slider is changed too fast. When initialized, the plugin creates a matrix with data corresponding to all possible values of the positions of the microphones. The more positions the matrix saves, the more detail there will be in the implementation. Unfortunately, this also requires more working memory, as the matrix is saved there. Here's an example with too few values in the matrix. The creation of this matrix is also why reinitializing the plugin takes such a long time. First and foremost, the plugin is made for music producers. It will allow them to get the plate reverb sound in a compact way. When the stretching of the plate and the dynamic microphones are used with moderate settings, they can add interesting sonic qualities to musical instruments or vocals. When used with extreme settings, they could be used to create sound effects rather than adding sound to musical instruments. Thanks for watching.